So in this video, we're talking about inequalities within triangles. So there's a relationship that you need to know about the position of the longest and shortest sides of a triangle compared to the positions of the largest and smallest angles in a triangle. The largest angle is always directly across from the longest side of the triangle. So that's what we see here in this picture. The largest angle of the triangle is always directly across from the longest side of the triangle. So if you can find the longest side, you know that the largest angle is always going to be across from it. And likewise, the smallest angle is always directly across from the shortest side of the triangle. So if you can find the shortest side of the triangle, then you know automatically that the smallest angle is directly across from it. And if one side of the triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So for instance, in this triangle ABC here, I know that BC is 5 and AB is 3. Well, what that tells me, since angle A is directly across from 5 and 5 is bigger than 3, then angle A has to be bigger than angle C. And then finally, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite of the smaller angle. So here in triangle DEF, we know angle D is 60 degrees, angle E is 40 degrees. So without really knowing anything else, I know automatically that side FE, because it's directly across from angle D, has to be longer than side DF, which is directly across from 40 degrees. Now I know that because 60 is bigger than 40. So again, EF is bigger than DF. So let's go ahead and do an example. We want to write the measurements of the triangles in order from least to greatest. So in problem A, we're talking about a triangle HJG, and we're going to compare the angle measurements. Okay, and also compare these side measurements. So obviously the angle measurements pretty easy. So angle G is smaller than angle H, which is smaller than. Let's actually do it this way. So angle G is smaller than angle H, which is smaller than angle J. All right. Now let's compare the side lengths. So. And we want to go in the same order. Since I started with angle G being the smallest angle, I want to start with the smallest side. So I'm looking directly across from angle G. So HJ is smaller than, now we're going to go to angle H. So JG is the next smallest angle, or next smallest side, I should say. And then finally, the last side is going to be the longest side, and it's directly across from 100 degrees. So HG is our smallest side, or is our largest side. So here we wrote the angles from least to greatest and our sides from least to greatest. It doesn't tell me what the side lengths are, but I can put them in order from smallest to biggest or biggest to smallest. Let's do the same idea with triangle B, which is QRP. Here I'm giving the side lengths. So let's start with those. Obviously QP is smaller than PR, and PR is smaller than QR. Okay, again, we got to pay attention to the directions. It said from least to greatest, so that's why I went from smallest to biggest. And now we can compare the same angles. All right, so QP, side QP matches up with angle R because it's directly across from it, and QP was the smallest side, so that means angle R has to be the smallest angle. So angle R is less than, let's see, here's side length 7, so that's RP, and it matches up with angle Q. It's directly across. So angle R is smaller than angle Q, and our last angle is going to be directly across from the 8, which is angle P. And that's it. We wrote our sides from least to greatest and our angles from least to greatest. Again, the only really way you can get this type of problem wrong is if you don't pay attention to directions. Like if you did biggest to smallest instead of least to biggest, you're going to get it wrong. So pay attention to what you're asked to do. And the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. So for instance, In triangle ABC, we have an exterior angle, which I'm just calling angle 1, and based on this rule that we just talked about, angle 1 has to be bigger than angle A, and it also has to be bigger than angle B. That's just a rule. So the outside angle is always bigger than each of the two interior angles that are directly opposite from it. And then finally, the triangle inequality. This is one of the most important rules out of this whole video, and probably out of this whole chapter, because it has a name like Pythagorean theorem, so the triangle inequality. So make sure you know this. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So for instance, in triangle ABC here in the picture, I know that side AB plus side BC has to be bigger than side AC. And I can do that for all three combinations of sides. The sum of two sides is always bigger than the third side if it's a triangle. If this inequality does not work, then you do not have a triangle. So in example 15, a triangle has one side of 10, another side of 14. We want to describe possible lengths for the third side. Okay? So let's start by drawing a sketch. Okay, so we're told that we have a triangle, and I'm just going to call this triangle A, B, C. You don't have to draw the same triangle I have, okay, just as long as it is a triangle. And we know that one side is 10. I don't know which side, so I'm just going to pick. So this side is 10, another side is 14. All right, well, based on the triangle inequality, we have three rules. So we know that AB plus BC has to be bigger than AC. We know that AC plus BC has to be bigger than AB. And finally, we know that AB plus AC has to be bigger than BC. So all three of these have to be true since this is a triangle. If even one of these fails, then you do not have a triangle. So now what I'm going to do is go through each of these and plug in what I know. So side AB is 10 plus BC is 14, so that's greater than side AC. Okay, so that's for the first rule. For the second rule, I have side AC, which I don't know, plus side BC, which is 14. So AC plus 14 has to be bigger than 10, because that's side AB. And then finally, for the last rule, I'm plugging in AB, so 10 plus AC, which I don't know, has to be bigger than BC, 14. So what I essentially want to do is to simplify and solve each of these. So 10 plus 14 is 24, so I know from this one that 24, so AC is smaller than 24. Again, you got to follow the inequality. So AC is smaller than 24. That's one of the things I know about this side. All right? Now here, I want to get AC by itself. So I'm going to subtract 14 on each side. So minus 14, cancel out. So I find that AC is bigger than negative 4. All right, well that kind of makes sense because since we're talking about lengths, AC cannot be negative. So we know that AC is bigger than negative 4 and smaller than 24. Let's finally solve the last one. So I'm going to say minus 10 on each side, minus 10. So AC is bigger than 4. All right, so now based on this information we have, we know that AC, sorry, I went up a little too high. We know that side AC, I'm going to put it in the middle, is smaller than 24 and bigger than positive 4. So this describes the possible values. So AC could be 4.1, AC could be 5, AC could be 10, AC could be 23. As long as it's within this range, we still can maintain our triangle. The only thing that's going to really change is this angle right here, angle B, because angle B is the side that's directly across from AC. So depending on what AC ends up being, then that's going to affect angle B. So this is our answer. We wanted to describe the possible lengths of what AC could be. So the length AC is going to be between 4 and 24. And we did that by using all three rules of the triangle inequality. So you need to make sure you know these three rules. Now, if you were given a different triangle that had side may be different letters. Okay, so the triangle inequality uses A, B, and C. What I would suggest is say if these had triangle PQR, just relabel it A, B, C. That way you know the triangle inequality fits up with it pretty nicely. And that's it for this video. As always, if you got questions, let me know.